Chapter 1.5.10 Networking on Windows. Kubernetes allows nodes to run on Linux or Windows, and you can mix both types within one cluster. This page offers an overview of networking tailored to the Windows operating system. Container networking on Windows. Networking for Windows containers is managed through CNI plugins. Each container has a virtual network adapter connected to a Hyper-V virtual switch. The Host Networking Service, HNS, and Host Compute Service, HCS, collaborate to create containers and attach VNICs to networks. HCS manages the containers, while HNS handles networking resources like virtual networks, endpoints, and policies. Windows HNS and vSwitch implement namespacing and can create virtual NICs as needed. Configuration details like DNS and routes are stored in the Windows registry database, not in files like Linux. Mapping files from the host into a container doesn't work in Windows. Windows APIs must be used to configure networking details for containers. CNI implementations must call the HNS to pass network details effectively. Network modes. Windows networking supports 5 different drivers modes: L2 Bridge, L2 Tunnel, Overlay, Beta, Transparent, and NAT. In a cluster with Windows and Linux nodes, it is important to choose a networking solution compatible with both systems. The Flannel CNI plugin is supported on Windows using the VXLAN or Host Gateway network backends. This plugin works with Flannel Daemon on Windows for node subnet lease assignment and HNS network creation. It reads its own configuration file and integrates it with environment variables from FlannelD. Flannel CNI can delegate to reference CNI plugins for network plumbing and provides correct configurations to the IPAM plugin. Various network flows are supported for TCP/UDP traffic between different objects such as pod, node, and service. IP address management. On Windows, supported IPAM options include Host Local, Azure VNet IPAM for Azure CNI, and Windows Server IPAM as a fallback if no IPAM is set. Load balancing and services. A Kubernetes service is an abstraction that defines a set of pods and provides a means to access them over a network. Windows nodes in a cluster can use different types of services such as node port, cluster IP, load balancer, and external name. Windows container networking differs from Linux networking, and additional details can be found in Microsoft documentation. There are known issues with node port services on overlay networking and pod-to-pod connectivity on a L2 Bridge network on Windows Server 2022. Workarounds and updates can be found at https://github.com/microsoft-windows/issues204. Limitations. The text outlines several networking functionalities that are not supported on Windows nodes. These include host networking mode, local node port access from the node itself, having more than 64 backend pods for a single service, IPv6 communication between Windows pods connected to overlay networks, and outbound communication using the ICMP protocol via certain plugins. The Windows data plane does not support ICMP packet transpositions for remote network communication. However, TCP/UDP packets work as expected. There are also limitations with Windows Reference Network plugins and the Flannel VXLAN CNI plugin on Windows. Node pod connectivity is only possible for local pods with Flannel v.12.0 or higher, and Flannel is restricted to using VNI 4.96 and UDP port 4789. For debugging connectivity with the outside world, using curl instead of ping is recommended.